Hello, welcome dear students. We are learning data structures and algorithms. The topic we are going to learn today is binary search tree implementation using C program. Okay, so when I say binary search tree operations, there are various types of operation like inserting a node in a tree or deleting a node. Okay, when we are deleting, there are three different cases. The node is having one child, two child, or zero child. Okay, and also we can display the binary tree. Okay, so for display we have different traversal techniques, that is in order, pre-order, post-order. So all these various types of operations we are going to learn today. So these are the different operations which we will be learning. In these operations, we can see that there is insert of a node. Display is done in three types, that is pre-order, in-order, and post-order. Okay, and then deleting a node, and then counting the number of nodes and counting the number of leaf nodes or the external nodes. All these functions we are going to learn by making a program for binary search tree. So now let us go ahead and understand it. The program. Here we can see the program for binary search tree. Okay, so initially I have declared all the header files required. Then I have declared a node definition. Okay, this is a structure which I am creating for creation of a node. As we see, the linked list, normally the node can have two items or members, and that is okay, one for data and one for the link or the next. But in tree, we have three different members, and the first member is data, second is left pointer and right pointer. So this way we have a data, left and right. Left and right are holding the address of the left child and the right child. Okay, so I have given the name for the struct is node. Yeah. Then I have declared all the different functions that I will be using over here. So the various functions that I'm going to use is, first of all, I will create my tree. This is a global variable declaration. So I'm declaring my tree as of type struct node globally. Okay. Then I have create tree function, insert element function, in order, pre-order, post-order traversal functions, delete node. Okay. Then total number. So after all the functions declaration, now let us understand the main function, that is integer main function. Okay. Here what I've done is I have declared some integer variables, option val. Then I have a structure ptr of type node. And then first of all, I am creating a tree. Okay. So I can create n number of trees in my program. So in this program, I'm creating only one tree, and the name of that tree is TREE tree, and this tree is nothing but a variable of type struct node which I have just declared globally. I'll show you where I have declared it. So this is line number 12 where I have declared a tree variable. Suppose if I want to use two tree in my program, I will be giving one name as tree1 and other could be given as tree2, like that. So first of all, I will call the function create tree. Let us see what this function is doing exactly. So we can just go and see the function definition for create tree. Okay, create tree is a function which is taking as an input one tree variable. Okay, giving nothing as output, so there is void as output, and what it is doing, it is just initializing your tree. So it is saying your tree is null. So initially your tree is null, that means you are declaring and defining an empty tree. So we are defining the tree is empty but tree is created, though tree is created but tree is empty. So initially always your tree will be starting from null. Okay, so this is the job of this function. So after creating tree, we are giving the value null to our tree variable. Okay, so let's come back to that particular code in the main function. Then I am giving all the different functions in a do while loop, because I want to give these functions many times that for user execution. That's why I'm putting all these functions in a do while loop, and inside that do while loop I'm using a switch case. So here if you see there is a do while loop. Okay, and in this I have given the different options. The first is insert element, then display using pre-order, in order, post-order, then delete the element, count the total number of nodes in my tree, count the total number of external nodes, that means leaf nodes. Okay, delete the tree and exit. Then it is asking for the option that I'm storing in this variable option. Okay, and that option I'm using in a switch case. So whichever number I'm pressing from 1 to 9 will go to the switch case and it will handle accordingly. If I press number 1, it will go to case 1. it will try to execute case 1. So case 1 is nothing but insert an element. That means it will ask me first of all, what is the value you want to insert in the tree? Say for example, I say, okay, the value I want to insert is 10. So it will store that value using scanf function in variable val. So val will hold value 10. Now I can call the insert function. When I'm calling, what I'm giving as a value, I'm giving, okay, what is it, which tree I want to insert and which value. So in tree, insert the val 10. After inserting the value in the tree will return you the root node of the tree if it is modified. So the root node is again saved in a tree variable, which is the same variable which I just gave as an input. Similarly, case 2 is going to display the tree. So elements of the tree, and I'm just calling the pre-order traversal display. So which tree that I'm giving as the input here. Case 3 is in order traversal. It will simply call the in order traversal function. Case 4 will call in order post order traversal function. Case 5 will delete a node. So before a deletion of a node, we can ask the user, okay, which value you want to delete from the tree. So that value will save in a variable val. So when I'm calling the delete function, I'm giving as an input the name of my tree and the value which I want to delete. And then it will delete that value and it will return me the root node of my tree again that I'm storing in tree itself. Okay, then case 6 is counting the total number of nodes. So this will directly call the function total nodes of the tree, and whatever number is given as an integer output will be displayed here. Then counting the total number of leaf nodes will also be called directly here, and then the output will be directly displayed as a printf function. So what I'm giving as an input to the function is only name of the tree. Lastly, I will call delete tree function. I will give the value of my tree root node and it will give back me the tree whichever it has deleted. And here we end the switch case. Okay, here switch case is over. And then I have finished the do while loop here. Here I will stop only if the option 9 is pressed, that is exit. Otherwise I will be in my do while loop. Then there is a get ch command written. Okay. So here we have end this particular function, and now here this is the end main function. Okay, after main function is over, we can go ahead and write down the function definition or the detailed task which every function has to do. Okay, we call it as a function definition. That I will do for all the functions. Now let us go and understand each of them in details. Okay, so first of all, we'll see how do we insert a node in a tree. Okay, so let's understand this function. Suppose if this is a tree already available with me. Okay, 41 is the root node and all the other nodes. I want to insert the value which is 44. So I'm taking from user the value 44 and I want to store it in my tree. So where it should go? In a binary search tree. In short, I have written BST, binary search tree. So let's just go and understand with the insert element function. It will take as an input your tree root node and the val. Okay, it will declare so many variables over here: PTR, node PTR and parent PTR. Then what it will do is, first of all, it will take a PTR variable and allocate some size to it. Okay, so PTR is a new variable in which I want to store the new element, that is 44. First of all, I will load the value 44 so ptr.data will be val, that is nothing but the value 44. ptr.left and right I'm saying as null, because I know the node which I'm going to insert is going to be the leaf node, and leaf node has left and right as null because it has nothing in the left and right. Okay, so I have prepared my ptr node in these 3 lines. So we can see, suppose here we can just say, for example, I have created a node ptr and ptr is having value 44 in it because ptr.data is equal to val I have done, and left and right I have written null, that means there is no address in over there. So ptr node is ready. I just need to attach it somewhere in my tree. So what should I do now? So now I will check if my tree is empty or not. So if tree is equal to null, that means the root node of your tree is null. That means your tree is empty. Yeah. So in that case, what should happen? The PTR is the first node of your tree, right? That means your tree should point to the PTR. So we can directly say your tree points to PTR, and here we get the first node of the tree. That's it. So tree is equal to PTR means tree is also pointing to the same node. Okay, and tree dot left is equal to null and tree dot right is equal to null. So with this we can just have a first node in a tree. Okay, when we go to the else part, when your tree is not empty, okay, so the node which you are adding is not the first node in your tree. बराबर है? So that time we'll go to the else part. When your tree is not empty, tree already has some values. Now how can I go and insert? So there I can just check. Parent PTR is declaring as null. Okay, initially I declare a parent PTR which is null. Node PTR is equal to tree. Okay, and so that we can say this is currently tree. Okay, which is pointing the root node. So I'm saying node PTR is equal to tree means it is pointing to 41. Now what I'm doing is while node PTR is not equal to null, जब तक node PTR null नहीं होता है तब तक हमें क्या करना है? Parent PTR is equal to node PTR. So parent PTR will point to node PTR. So now here parent and node both are pointing to same node. Okay. And now what I'm doing is if value of node PTR, if node PTR dot data, node PTR dot data मतलब कौन? 41. If 41 is greater than val, you see val, what is val? Val is 44. So if val is less than node PTR dot data means 44 is less than 41, in that case this condition is true or false. So if we check here, this condition is false, and though the condition is false, what we can do is, okay, we'll skip if and we'll go to else, and node PTR is equal to node PTR dot right. That means node PTR will go to right of 41. So node PTR is now pointing to 50. Now again I go to the start of while loop. Whether node PTR is null? No. So if it is not null, I will still go inside the while loop. And here what I'm doing is parent is equal to node PTR. So now again your parent is pointing to 50 and node PTR is also pointing to 50. Now I'll check. If value, that is 44, is less than node PTR, so 44 is less than 50, yes. So now my condition is true, and though the condition is true, we will go inside the if loop. So if condition says node PTR is equal to node PTR dot left. So now your node PTR will go to left of 50, but left of 50 में node जाएगा, but left of 50 is empty. That's why your node PTR is now equals to null. Getting it? So now what will happen? We are coming out of while loop because node PTR is now null, and now I will check if value is less than parent PTR dot data. So now parent PTR is nothing but 50. So 50 से 44 is less. Yes, that means ये if condition true हो गया. Then what will happen? Parent PTR dot left is equal to PTR. So parent PTR के left में मतलब 50 के left में PTR will come. So it will now point to PTR. So 44 will come to the left of 50. So with this we can just add a new node in a tree which is empty and which is full also, which is having some values. At the end I am changing the tree, that is the root node of my tree, if I am changing it at all. Okay, so this way what we are doing is we are done with the insert function over here. Okay, so this is all about the insert function. So then we can see that the node which 44 is added at the left of 50 like this. Okay, now let's go ahead and understand the next function, that is displaying the tree. We can display the tree in three different ways: pre-order, in-order and post-order. Let us understand the pre-order first. Pre-order means what? Your data is displayed first, that means root node data. Then we go to the left side and then we go to the right side. Okay, so this way we traverse in a pre-order traversal. So let's say this is a tree. I want to traverse this using pre-order traversal. How will I go ahead? Okay, so here there is this function Pre-order traversal. The function is really very easy and very small. Okay, so very easy to remember. What it is taking as input a tree, it is not giving anything as output because it is not changing your tree, it is just displaying it as it is. Yeah. Now the first condition that I'm checking is if the tree is not equal to null. Tree is nothing but your root node. अगर मेरा root node null नहीं है, that means your tree is not empty. So if tree is not empty, then we can display it. But if it is empty, we cannot display. So else में क्या होगा? Function will stop, end. Okay. So if tree is not empty, then only I will execute this 3 lines. Now here the tree is not empty. So your tree is pointing to 41. Yes. So now I can say my tree is not empty and I can display it. So let's say what happens here is, the first thing happens is printf. We are displaying the tree.data. Okay, so what I'm doing is the first time I'm making a function call, that is this pre-order traversal function, and I'm giving as an input 41 is coming as input here, that is a tree node. So what it will do, it will display the first line, that is display the tree.data. Then it will say, okay, in pre-order traversal, you can see there is this recursive call to the same function. The function calling itself, लेकिन अभी वो खुद वही ट्री को इनपुट नहीं दे रहा है. यहाँ पे इनपुट क्या हो गया? ट्री का लेफ्ट चाइल्ड, दैट मीन्स लेफ्ट सब ट्री ऑफ योर रूट. यस, और उसके बाद सेम प्री ऑर्डर ट्रैवर्सल राइट सब ट्री को जाएगा. सो पहले ये वाला सब ट्री का कॉल एग्जीक्यूट होगा. सो व्हाट विल हैपन नाउ, इफ यू सी हियर डेटा लेफ्ट राइट, दिस आर द 3 लाइन्स. सो DLR we can say. Yeah, so now let's understand the second line. When the call goes to the second function left of the root, that means it goes to the number 20. So again for number 20, the function is started from beginning, and again I say, okay, 20 is not null, that means I will come and display the value 20. So here I'll display the value 20. Then again it will say, okay, go in pre-order to the left of 20. So again I'm going to the left of 20, that is 3. So 3, again make a function call, again I'm displaying 3, and okay, now there is nothing on left of 3. So what will happen, if nothing there on the left of 3, we will say, okay, now go to the right subtree. But again there is nothing on right of 3. So what it will do, the function is closed. When the function is closed, it gives back the cursor to the previous calling function. Previous calling ने function को 3 को यहाँ से call किया था, left of 20 का left was 3. Okay, उसने left को call किया था. अभी 20 will make the call to its right function. So that means we are getting a function call to 27. Here when I get function call to 27, it will first display 27 and call the left and right of 27. But I guess there is no one in the left and right, so it will go back to the calling function. So 20 has done all DLR statement. It will also go back to the calling function. But 40 has executed only D and L. Okay, so now R is pending, so it will make the call to the right child. So right child call will be done, that is call to the 50. Now 50 will display the value and go to the left. Okay, so again it is displaying its data and going to the left. So at left I give a call to the 44, and 44 is, first of all, it will display the value and then it will say go to the left and right, but there is no one on left and right, so it go back to 50. 50 says, okay, now I'll go to the right child, but there is nothing on right child, so it is done with all the DLR functions. It will again go back to the calling function. The calling main function 44.1 will say I have done all the different subcalling and the recursive calling of the functions, so then it will stop the function. So now we will come out of the function at line number 130. With this we have used, or we have seen, the pre-order traversal functions, how it performs recursively and give us the output in pre-order traversal sequence. Exactly same way we are writing all the other traversals, that is after pre-order. In pre-order we have data first, okay, then left and then right. But in in-order traversal, what do we do is, we first call left, then data and then right. Okay, and in post order what we are doing, first we are calling left, right, and then we are displaying the data, that is the root node. So in order traversal, you can see the first call is to the left subchild, then for data printing, and then call to the right. So whenever I have L or R, I am calling the left child or right child recursively with the same function. Okay, similarly to the post order traversal, again it is left and right call first. So first call to the left, then call to the right, and then display the data. This is a post order traversal, same function is recursively called. So this way we can just go ahead and see the other functions, that is in order traversal. So here in order traversal, first of all 41 will get a call. Okay, what it will do, it is saying LDR. So it will first go to the left, it will not display the value. Yeah, then again it will go to 20, again say LDR. So it will go to the left but not display the value. Now it will say go to the left at 3. Okay, and at 3 there is nothing on left, so now it will display the value of 3. So it will display 3. Then it will check there is nothing on right, so it has done with this particular node. It will come back. Now it will display 20. After displaying 20, it goes to the right child, and right child call will be made to 27. 27 will display the value. It will again come back to the calling function. Now 20 will come back to 40. Here I will display 41. After displaying 41, I am going to the right child. That means function call to 50. 50 will say again LDR. Okay, so LDR. So it will first call L, that is 44. 44 will display the value, and once 44 come back to 50, it will display the value 50, and then it will say okay, now I have done my job. So it is again going back to 41, and then we stop the function. Similarly, it happens with the post order traversal. Post order traversal, we have L, R and D. So we will have first call to 41, then left child 20, then left child 3. Okay, now 3 left and right, nothing is there, so now I'll display 3. Again I go back to 20, but 20 says okay, you go to the right child, that is 27. So 27 will make a function call. Okay, and 27 will say there is nothing on left and right, so display the data 27. After 27, go back to 20. Now it will say okay, my left and right is done, now display the value 20. After 20, go back to 41. 41 say okay, left is over, now I'll go to the right first. So now 50 will go to the left, that is 44, and 44 will now make a function call. Okay, so 44 left and right, there is nothing, it will display 44. When 44 come back to 50, it will say okay, go to right, but there is nothing on right, so now it will display the data of 50, and then it will go back to the root node, that is 41. 41 says okay, now left and right is done, now you display the value, that is 41. So here we stop with the post order traversal. So with this we have seen all these various display functions. Okay, and those functions are really very easy and concise, and we can understand them. Okay, so they are just nothing but a recursive function callings. Yeah, so now we'll understand the main important function of this particular program, that is deletion of a node. So this delete function and the other remaining functions we'll understand in details in the next part of the same video. Do watch the next video.